Okay.
No, I don't have any questions.
Okay, Seth. Okay, just to let you know, Michaela, you already know, but for anyone watching this video, Seth is right here on the phone. He's having major internet issues. He tried to get on and he just couldn't for whatever. His internet kept crashing. So we're gonna walk through the quiz with him. He's gonna write down the answers. And he'll input them later. Is that, but Michaela, you can hear Seth. Seth,
Yeah.
say something. Okay, good. All right. So we'll go ahead and start the first question on quiz. Seth, you didn't have any questions, did you? Oh,
no, I didn't have any questions.
I just got an email from Garrett saying he dropped the class.
Okay.
Oh, okay.
Okay. All righty. Another one bites the dust.
I was actually just thinking, not even kidding.
Okay. Yeah, it's not easy. It's not easy. But okay, group meeting quiz. I'm going to go ahead and start it.
Okay. So our question 3, right?
Question. Oh yeah, hold on. Haven't got that far. One sec. True.
So the first 2 questions that are
True, false. Correct. So we really start on question number 3.
So it says, in a pie chart, why are the slices or different sizes? And it says the size of each slice is random. The size of each slice is determined by the number of categories. Each slice represents a category, and the area of each slice represents the portion of the total occupied by the category. A pie chart are more visually appealing when the slices are different sizes. And I picked C.
Okay, let me go through that one more time for Seth. So in a pie chart, why are slices, sectors, different sizes? In each slice, we're going with each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. Does that sound correct to you?
Yeah.
Okay.
So
the other choices were the size of each slice is random. Obviously not. Size of each slice is determined by the number of categories. No. And then the pie chart is more visually appealing. And that's no.
So Thomas, do you want to read the questions? That way Seth can hear him better.
Yeah, I'll do that. Good idea.
Okay, and number 3 is C then.
So number 3 is C. Yep.
Okay, yeah, I hear it a lot more clear when Thomas.
I imagine so.
Michaela, but it's a little harder that way.
I'd imagine. No worries. And it says, how are bar charts and Pareto charts related? The difference. So I know what it is. There's something like the Pareto is in order. So, okay, yeah. So the Pareto chart and the bar chart are the same thing, but a Pareto chart is when the bars are organized from largest to smallest, going left to right. So
or more to the other one. It usually goes like that. Yeah.
Yeah. So the correct answer for number 4 is C.
Okay, and what was that answer of what's the exact wording?
So it's the only difference between a bar and a Pareto is a bar chart ordered from largest to smallest.
Okay.
Okay, we conclude that P hat is normally distributed if
N times P is greater than or equal to.
Yeah, so if N times P is greater than or equal to 10 and N parenthesis 1 minus P is greater than or equal to, or is greater than or equal to 10. Okay. If P is the true proportion of is P the true proportion or the sample proportion? P is the true proportion.
Yeah, because P hat is the sample, right?
Correct.
Okay.
So
I feel like that one's too easy to answer, and so I'm a little worried.
I know, yeah, me too. But there's some of them that are just like that. They're just super simple. So number 5 is P, or sorry, is B as in boy. which is true proportion.
Okay, and that's, so P is a point estimator for true proportion.
Yes.
But P hat
Yes,
is the same.
that was in
P represents, well, P represents the true proportion, not the sample proportion. That's what it's asking.
yes, that's true.
Okay. All right, so number 6. What is N? The sample size. So that's C. Number 6 is C.
Okay.
So number 6 is D.
C is in cat.
Oh. What was the question again? What is N?
What does N mean? And it's just a sample size. Okay. Alrighty. If P equals 1/4, what is the smallest N that satisfies the requirement? It's a little difficult.
So is it trying to be, is it trying to say like what, you know how it has to be equal to or greater than 10?
Yeah, so that is what it's asking.
2.5?
Or
Because it'd be,
So what you're gonna, I don't,
so you just take
what is it?
P and divide that by N, and then you would take, well, yeah, you take that and divide it by N, so then you take that and divide it by 10.
it's kind of on the right track, but what you got to, you got to consider the other one too, because there's,
Oh, it's 40.
yeah, so you're gonna take, you have to make sure it satisfies both at least, and then you take the smallest number because it's asking for the smallest number of N.
Right.
So we take N. Wait, no, wait, what is it?
N times 1,
Oh yeah, N parenthesis 1 minus, and what was P? Minus 0.25.
oh, you're saying do the other equation too, not just the one. That makes sense.
Yeah, 'cause you got to do 2. Yeah, does that make you understand? Okay.
divided by the number.
So
we're solving for N, and we're setting it. So we're solving the equation. We're just plugging in 0.25 for P, and solving for N, and we should set it equal to 10 because it has to be 10 at a minimum. Does that make sense? So it's,
Yeah.
well, I need to count.
so that, yeah, so we're looking at 1 minus 0.25. We're at 0.75, and then we take 10, and we
1
take,
minus 0.25.
yeah, and then you take, and then so now it's N times 0.75 equals 10.
So we divide that by,
And then we take 10 divided by 0.75.
okay. But then we have to do the same thing on the other side. So it'd be,
Mm-hmm.
then it would just be 10 divided by 0.25, right?
10 divided by point, yeah. Mm-hmm.
Okay, so it'd be, so then it's the 13.33.
So that's what I'm doing. We got 13.233. And then what's the answer when you do it the other way?
13.333.
Oh,
And the
sorry,
other-
that's what I got too.
Yeah, okay.
I don't know why I said 2. Okay, but then when you do it the other way, you got 0.2, you do 10
No, I got 40.
divided by
Divided by
0.25.
equals 40.
Okay, so I think the answer is 40 then.
No, because we're looking for the smallest.
I know. Hold on. Let me think real quick, because what happens if we use? So now let's plug in 40 for N on both of them, and so on that one we're above 10. Then hold on, my brain's hurting. So I did this already.
Okay.
So hold on. So if we plug in 13 on both, it should work. Yep. Okay. Sorry, just had to work that out in my head. So we're at 13.333. Oh, hold on. But we rounded up to the largest, to 14, right?
I thought it said, hold on, let's go back up.
It
When
says,
you calculate anything, make sure to round to the third decimal.
I know, but do you remember on this one, because we're solving for N, N cannot be a decimal.
Oh, I didn't know that. Okay.
Do you remember? Because we can't take a third of the sample. We have to do a full number.
Okay, so wouldn't it just be 13?
Around 13 wouldn't it round this down to 13?
Well, when you're solving for n, you always round up.
Where does it say that?
It said that in the lesson. So, because we're trying to find out the number of samples we should get to reach the requirement.
Mm-hmm.
And you can't. And if it came out to 13.33, you can't get 0.33 of a sample, and you shouldn't round down because then you're going lower. So to be safe, you always go up.
Okay, that makes sense.
Okay.
So for 7, what equation are you guys? Are you using n equals z
No.
n parentheses z divided by n squared?
No. We're doing n parenthesis 1 minus p parenthesis greater than or equal to 10, and then we just plug in p for we plug in p of 0.25, and then we just solve for n algebraically.
So it's n parentheses 1 minus p as in pair.
P as in Perry.
Yeah.
And then a closing out parenthesis, and then is greater than or equal to 10. And then we plugged in 0.25 for p, so we got 1 minus 0.25 is 0.75. And then now we have n times 0.75 equals 10. And then we solve for n algebraically by dividing 0.75 to both sides.
So it's n minus p, which is 0.25. So wait, what's n? So n equals? Is that correct?
No.
Or n times?
So it's n times 1 minus 0.25.
Okay, and what's n?
N, we don't know n. We're solving for n.
Oh, okay.
So.
And so then.
And we set it all equal. And we set it all equal to 10.
Equal to
10. And we know we have to be at minimum 10.
Equals to 10, and then you divide it over to the other side.
Yeah, well, first you just solve, you do 1.1 minus 0.25, you get 0.75, and then you divide 0.75 from 10, and then you get 13.333, and then you round that up to 14. Okay. All right.
That makes sense.
Okay. So moving on to question number 8. Okay. So question 8 says, suppose n equals 24. Okay. And p equals 0.4.
Okay, same thing, but with these numbers.
This is a different question. Yep, different question. So now we're going to be using the formula that we learned in lesson 16.
So what is p hat?
So what is p hat? Correct. Okay. So on this one, yeah, we are solving. Wait, what's the p hat formula? I think it was just 1 divided by something. What was it? Okay, p hat is p parentheses 1 minus p divided by n, and then you square root that whole thing.
Isn't that the standard deviation though?
Okay.
Actually, it might be.
Isn't it just p over
So that's the square root of p times 1 minus p divided by n, correct?
Hold on 1 second.
That's the standard deviation.
Yeah, I think it might be. I'm trying to remember. Because it says p equals x over n.
Yeah.
Oh, but we have p.
Oh, so you have to solve for n. So then it would be n times 0.4?
Don't we have n?
Yeah, so would it be n times p?
No. I don't think so.
Is this round to the nearest 10th place?
Okay. Because if you see here, because we have p, we don't have p hat.
Right.
We're trying to solve for p hat.
So.
And you're saying what? So what formula do you think it is to find it?
I have p, the formula, because I wrote all the formulas down. So I have p equals x divided by 9. So wouldn't it just be n times p then?
You have x divided by 9?
Sorry, x divided by n.
Equals x divided by n.
Oh, but I have p hat equals x divided by n.
Okay, so then
We
we're
don't have
divided. Let me see.
no,
go
but
back.
because we don't have x, or do we have x?
So,
Is it
is
called
x-
p? Px?
Oh, it's px, is it? Actually, it probably is then. I don't,
Yeah, so I'm looking at the, okay, so let's see. Pulled in x equals 35 of the response. So n was so it looks like x is p.
okay, well then we take 0.4 divided by 24, and we get 0.016. We don't even have a 10th spot.
So wait, 0.4 divided by 24. I got 0.016666667.
Yes. So we have to round it to the 10th space, and we don't even have a 10th space. So we gotta. So either the answer is 0 or
0.0.
I got a question.
I don't think
So
that's
what, can
correct.
you repeat the question one more time? Exactly what it says.
Okay, so suppose n equals 24 and p equals 0.4. What is the value of p hat? Or what is the mean of p hat?
Oh, here we go. Oh wait, that's standard deviation. Never mind.
I know, that's what I was looking at too. Sample distribution. Oh man, this is a tough one, guys. Oh boy.
I'm thinking that's it. I mean, I know it seems weird, but.
You think it's 0? Okay.
Oh wait, hold on. Oh wait, it says the mean of p hat equals p. But I guess we're not
Oh,
trying.
duh. We're so dumb. Oh my gosh. Of course it's 0.4. The answer is 0.4. How dumb are we? It's that same question. It always equals the same.
That's
Thank
right.
good catch, Michaela. That was awesome. I feel so silly now. Okay, so p hat. I'm gonna write that down. P hat, or p equals p hat. Okay. Good catch. Good catch.
Okay.
So answer 0.4. Jeez. What is the standard deviation? Okay, now we're gonna do the formula.
That's
Which is-
0.4 times 1 minus 0.4. Because that, and then divide that by 24. Okay.
And then square root that whole thing, right?
Yes.
Okay. So I'll do it on our own and see if we all come out to the same.
Okay, I got an answer.
Wow, that was quick. I'm not that fast. All right.
I got an answer too.
1 second, guys. Sorry. You guys get 0.1?
Yeah.
Okay.
The square root of 0.01, yeah. And then square root of
Good job. All right, we all got the same thing. All right, question number 10. New question, Steph. And we're gonna use it. We're gonna use it for the next 4. So, let me see here. Okay, so Brittany's batting average is 0.3. We want to determine the probability that she will hit 35 hits in her next 100 at-bats. So n equals 100, and p equals 0.3.
Wait, that's 35 hits. What is that number?
That's gonna 35 hits.
PR equals 2.
I think that's gonna be our
Like,
alternative. Yeah.
Okay.
So. Okay. So we have question number 10. Is what is p hat? We know it's 0.3, right?
But it says round to 2 decimal points, so it'd be 0.30, right?
Yeah, or point. You never have to put the zeros, but because I never do. But yeah, 0.30 is correct.
Okay, so number 10 is 0.3 because we're being asked what is p hat.
Yeah, p hat. P hat equals p. So.
Okay.
I like it. I like that it's called p hat. It's kind of funny. All right, what is the standard deviation of p hat? So now we're going to do that same. So we're going to do that same formula we just did. So we're going to do 0.3.
This is for number 11, correct?
Yes. Yep. 0.3 times 1 minus 0.3 divided by 100.
I wasn't sneaking. What are you talking about? I got an answer.
All right, one sec. Are you rounding the 3 decimal place? I got one too. You ready, Seth?
No, almost. It's a little harder with the baby.
I bet.
But she's so cute.
Almost there, though. She just has her own opinion on what the answer. Okay, good. I do have an answer. It's 3 decimals. I got 0.046.
Okay, me too.
Same.
Okay, cool. All right. Moving on. Same data, Seth. Question 12.
Okay.
Find the z-score. Okay.
Okay. And that is value minus mean over standard deviation.
Let me double check. So I have it as p hat minus p divided by divided by the standard deviation, which was what we just did. Does that make sense?
Yes, correct. That's what I got.
And p hat is going to be 0.35 now.
So p hat is 0.35 because that's our alternative, and then it's minus 0.3, correct?
Yes. So that's weird because I thought p hat was equal to p. That's kind of deceiving.
Yeah.
So is question 10, should it be 0.35? Or I'm not going to worry about it. I'm just going to go with that. Okay.
Hold on a second. My computer.
Okay, I've got an answer as well.
So
Okay. I got 1.087.
wait, I'm confused.
Okay.
So for the equation for the z-score, is it p hat minus p over the standard deviation, right?
Yeah.
So wouldn't that be 0? Because if p hat is p.
Yeah, but in this situation, they're testing to see if p hat is going to be 35 because that's what I was confused about. But it's probably going to be at least 35.
All right, so for 12, did you guys get 1.08695?
Yeah, 1.087 if you're rounding, correct?
Okay.
Okay.
So that's what we all concluded to?
Michaela is questioning it, as mine, because it should be 0, but the answer is not going to, because if you divide 0 by 0.046.
So wait, how did you guys come up with the equation you guys got then?
So I got 0.35 minus 0.3.
How do you get 0.35?
From 35 hits. She wants to get more than 35 hits.
Oh, that makes sense. Okay. So you do 35 minus 0.3, right?
Or no, 0.35 minus 0.3.
0.35 minus 0.3. Okay.
Yeah. Mm-hmm. Does it make sense how we got that?
Yeah, and then divided by. Yeah, I got this.
So to get that answer, you want to do, if the coin toss, say, n equals 25 times and heads is 17 times, the sample proportion of heads in p hat, which equals x over n, which equals 17 over 25. So if we do divide it by that number,
Oh, so that's what x is.
35 divided by
That's what x
100.
is.
Okay, so then
Our mean,
we want to do 35 divided by. Okay, so then p hat, we got to change number 10 to 0.35.
I don't know. See, because then it's changing. So I think if you want to do 0.35, and then I'll do 0.3, and
Okay.
then we'll see whoever got the right answer, because that one's tricky. Because the other one, it was just because it says it equals p hat equals p, but then it also says p equals x over n. So I'm not sure at this point.
Right.
But now we're solving. So this next question on question where are we? 13. It asks what's the percentage of that Brittany will get at least 35 hits. So we're asking what's the percentage that she's going to get 35 hits and above.
Okay.
So now we just plug in the 1.87 into the applet, and then we highlight everything above, and then the area is our percentage.
wait,
So you can't do if you don't have your computer up, Seth, you're not going to be able to do it. You'll just have to trust us.
So 1.8.
what are you guys doing? What are you guys plugging it into?
So I'm plugging the 1.87 into the normal probability applet for the z-score, and then we're doing the high, the one to the far.
1.08, right?
Yeah, 1.087. You plug that in for z-score,
And
and then you highlight
above it?
everything to the left, and it should the area I'm getting is
0.1385.
yep 0.1385. So 0.139 is the answer. You can double check that when you're plugging it in on yours.
Okay, and so you're highlighting the centerpiece and the far left, correct?
No.
Because it's on the
No,
right
because
side?
we know the average is going to be 30 is 0.3. So when we're going 0.35, we know it's going to be on the right. So we're only highlighting the far right tail.
Oh, so not the far left. I thought the far left.
No. So I may have said that in misspoke. But yeah, just the far left tail, not the middle. Sorry, just the far right tail, not the middle. Or the
Right. Okay.
Okay. New question, Seth. We're going to use this
What was the answer for 13?
0.139.
Okay.
Okay, new question. It says, this is for the last three, 14, 15, and 16. Okay, it says, it says, if the true proportion of people who support a political candidate is P equals 0.052, or sorry, just 0.52, not 0. So P equals 0.52, and N equals 2,000. We want to determine the probability that the results of the survey will suggest that a candidate is losing the election, getting less than 50% of the votes. Okay. So what is the standard deviation of P? Okay, so solve for the standard deviation.
I always
So
get really
P is-
confused because I keep forgetting you have to square it at the end, and I was like, that answer doesn't make sense. And then I figured it out.
I know, I hate that. I hate that. It tricks me up too. So P equals 0.52, N equals 2,000.
And then what p hat equals?
We don't know P hat yet.
Now,
We don't. We don't know p hat
That's
yet.
what we have to solve for first.
Hold on.
Not for standard deviation, because that's just p times 1 minus.
Okay.
Yeah, standard deviation just uses p, not p hat.
Yeah, I got it. Right.
But p hat just equals p, right? Or sometimes.
Yeah, sometimes, but in this, because we don't know x in this situation, so
Right.
I guess it just depends on whether you know x or not. I think that might be it, but I'll have to double check. I might rewatch the videos because I think I might have been falling asleep during these last ones. I missed a lot. All right, so sorry, I'm just going through it real quick.
Wow.
Um,
Hopefully you guys got a very low number. Okay.
Did you square it? Or square root it?
No. Okay.
That's what I did too.
We were just talking about that. Okay.
All right. Not bad. Did you guys get?
Well,
Let me know when you guys
we got 1 sec, almost there.
decimal spot.
I believe so. So 0.011.
Yes. So I got 0.0111.
Yeah.
Sorry, what did you guys get?
0.011.
Yep.
Okay.
That's for 14.
That is for 14. Yep. All right. What is the z-score? Okay. So p hat is our alternative. And for the alternative, we're going to use 0.5 because we're trying to find out what's the probability of the other candidate losing.
Okay.
So value equals 0.5 or mean equals 0.5?
P hat equals 0.5.
Okay. That makes sense.
Hold on. If you attribute portion of people who supported okay. So P, there's a formula. Dagnabbit. Okay. So Z equals 0.5.
0.52 is the true. Forgot what it is.
0.52 is P. 0.5 is P hat.
Yeah. I know, but in the sentence, what does it say?
The true proportion.
Okay.
Okay. So.
I got my one.
Sorry, 1 second.
Yeah, no problem.
Oh, we can just use the one about.
Okay.
Let's see. I got a z-score of -1.818.
I got -1.790.
Huh.
Ooh. So did you use 0.5 minus 0.52 divided by 0.011? That's what I did.
Yeah, that's what I did
well,
too.
what I did is I did 0.5 minus 0.52, and I got -0.02.
Yeah.
And I just divided that, but I plugged in the whole answer because it says not to divide until you completed your thing. So I just plugged in the whole big number without rounding it, and that's why I got the point.
So you plugged in. So you plugged in more numbers than 0.011.
Yeah. Because it says not to round until you've got your complete answer.
Okay, what was the answer that you got?
Well, it was 0.00. It was 0.011, but then the full thing is 0.0117139.
1.791.
Yeah. So the what Z-score did you get again?
I got negative 1.790.
Okay.
Oh, well,
So
you
here,
just plug in, if you plug in, if you divide by even a bigger number, you can get negative 1.791.
yeah. Here, so what I'll do, because I think when it's this close, again, because we put different answers before and we've come out to the same, we both got them right. So I'll put negative 1.818, and then Michaela, if you do negative 1.790, one of us is right. You had a good point. So I'm not 100% sure.
Yeah.
So negative 1.818. Okay. What is the probability of the candidate losing, even though the true P is 52? Okay. So now we plug in negative. We're gonna each come out to our different answers, but we'll just stick with it and see.
Hey.
So what are we trying to solve for now? Are we?
What's that, Michaela?
So I just submitted because I finished. Question 7, while you guys are still in there, it's not 14.
Question 7?
Yeah.
Okay.
Where we put 14 because we were rounding up.
What did you get for 16? Did you get 0.0345?
16. I got 0.037.
Oh, that's right. You rounded it. Okay. Let's.
Wait. We're on 16, and what are we solving for? I didn't hear that.
Oh, so we're finding the probability. So it's the applet. So you just plug in the.
Oh, okay.
You plug in the negative. But on those last 2 questions, did you get them right, Michaela?
Yeah, I did.
You did. Okay.
I also got the 35 right. It's only question 7 where it says 14. So do you want to go ahead and put 13 in there and just see, and then
The 13.33.
not the 13.3, but because I guess if it has to be a whole number, try 13 and see. But do you want to put?
So
13?
it's definitely not rounding down. So if it's not 14, I'm pretty confident it's going to be 13.33.
Okay.
So yeah, I'll do that. And then Michaela, let me get those answers from you again. Actually, I'm just going to submit it how I got it, and then I just want to.
I think that's smart.
Well, we'll catch you up to speed in just a second, Seth. I just wanted to make sure we're all, me and Michaela, on the same page. So 0.35. 0.035.
So if I call the PowerPoint the weight of a smile, is that too cheesy?
That is actually very clever. I like it. Huh. 13.33 was wrong as well. Okay. Michaela, what did you put for number 10, Michaela?
10, I got 0.35. What did you get? You just did 0.3?
I did 0.3. 0.35 must be correct because I got it wrong. So 10 is 0.35. Okay, so.
Did you get the last 2 right?
Yeah, I did.
Okay.
So
we probably just accepted both depending on what people did.
Yeah. So 10 is 0.35. Well, what's that, Seth?
What is 16? I didn't hear the last.
16 is 0.035. And then 15, if you put negative 1.818, that will work as well. So both ways work apparently. So 10 is 35, is 0.35. Okay, let's look at 14 again, or 7. So if P is 1-4, what is the smallest n that satisfies the requirement? It's got to be, but I was so certain that it required a whole number. I'm going to just go look at the notes again real quick and just, because he was very...
You did 0.3, right?
Yeah, I did 13.333.
And it was still wrong?
You got it wrong, yeah. So, and that's what you guys got, right? That's what we got when we inputted it?
Yeah.
So are you guys talking about 7?
Yeah, we got it wrong.
Okay, and so can you read that question one more time?
Yeah, it's if P equals 0.25, what is the smallest n that satisfies the requirement? Oh boy, that's a tough one, man. So let's do, if P equals, what was P again? Just write it down. If P equals 0.25. What is, let's see, so do P, I think it's 40. No, hold on, let me think. No, it can't be 40, that's stupid of me. Hold on.
Okay.
Okay, Michaela, it is 40. So look, so if we do 13.33 times 0.25, it's not greater than 10. That it doesn't meet that requirement. 40. It has to be 40.
Okay. Did you put in 40 and it worked?
I haven't yet. Let me do it. I have to do the whole thing, but I'm 100% sure it's 40. Okay. That's 740.
Let's just do that.
Oh man, we still have another one. Man, this is a long lesson. Oh, come on, stupid computers. Give me a minute. I just got to punch everything in.
You're good.
And well, I'm using my wife's hotspot now. It's still loading, but I can test this 40 works.
Okay. Group quiz. Here we are. Seth, what part of Arizona did you grow up in?
Phoenix, the city of Phoenix.
Okay. What high school did you go to?
I went to Thunderbird, so that's the northern part of Phoenix.
Because I work in Phoenix.
What part?
I work
like
right.
Green Valley.
So I work. It's called. Do you know where Copper Point Tower is?
No.
It's like right next to Brophy High School. So it's like on.
What?
It's on like McDowell and 3rd. It's right next to Brophy.
Oh, okay.
So number 740. Yeah, I'm 100% sure. Okay. Actually, I shouldn't say 100 because I'm not 100, but I'm very confident. All right. Are you in it, Seth? Is it going for you?
No, I think the best solution would be for me to call. If my hotspot works, unless I'm on the phone using it. So it might be best if I call from my wife's number.
Yeah, why don't you try to have your wife call my wife?
I know. Crazy.
And you said 10 was 0.35, right? Is that right, Michaela?
Yeah. Sorry. I was working on the PowerPoint. I'm trying to multitask.
Already, you're starting early. I like it. Yeah, I hate group projects, but I think we got pretty lucky with our group because some group projects are just
It
awful.
depends. Yeah, it depends. I mean, I've had some good ones and some bad ones.
I have to wait until we get lots of the data to do the PowerPoint.
Yeah, well, she's just starting on it. Yeah, there's a lot of data we still have together.
Yeah, I'm just doing the layout and putting the slides and organizing them. That way I can just know where everything's going.
Yeah. And
Okay,
so,
are we on to chapter 17?
did you submit?
Yeah, I've submitted.
Oh, did it? Was it 100%?
Oh, I didn't go back and do it.
Okay.
I'm okay with one. It doesn't really bother me. I know I should care, but no.
I care. I'm a perfectionist.
I'm,
Yeah, because on the group on the homework this week, I missed one. It was the first time I got one wrong, and and I missed it twice. It still bugs me. Okay. Sorry, I'm just
I'm
gonna
a
go.
select perfectionist, so I pick and choose.
It's okay if I hang up really quick.
Yeah.
And then call
Hang up and call me back.
Oh wait, they just closed it.
I'm gonna be right back.
Oh yeah, go ahead.
We're going to come back.
That's wrong. So I'm gonna hang up and call.
Okay. You want to submit it with 40. Yes. The answer's 40. 100%. Thank goodness. Amen.
Hey, so it's moving a lot quicker.
Okay.
So
Yeah, so the answer was 40. I just checked, and I got 100.
okay. So 3 is each line represents a category. 4 is well the last answer only the bar yes is that Pareto comes from a one. And number 5 is true proportion. And it's simplified.
40 is correct answer. Yep.
So how did you come up with that? Because I remember doing 1 minus 0.25, and then you divide that by 10. Well, 10 divided by 0.5.
Yeah, and then your answer was 13.33.
Yes, and then we rounded up to 14.
Yeah, so I was correct on this. It always has to be a solid number, but so now we know. So now let's just plug our answer into our equation there. So it has to satisfy two different things. It has to satisfy n times p equals 10, or n times p minus p, or n times 1 minus p is equal to 10. It has to satisfy both of those. So if we plug in 13 for the second equation, it equals 10, fine. But if we plug in 13.33 into the second equation, it doesn't work. It doesn't equal 10. But 40 would. So it's tricky, but you just gotta, what I would do in these situations is I would solve for n both ways, and then get your two answers and try them on each other, and one of them will work and one of them will not. And you just got to do the one that works. I know it's extremely confusing. That's why it took me so long to figure it out.
Okay, so you have to test n times p is greater than 10, and n times 1 minus p is greater than 10?
Yeah, you have to, or greater than or equal to, but just for the algebraically, just set it equal to. Set it as equal to. And then, so we got, for one we got 40, for one we got 13. 13 works on only one of them, and 40 works on both.
Because what is, what's n in this scenario?
And we're solving for n. We're trying to decide what n is going to be.
Oh, okay.
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 All right. You guys ready to start the next quiz?
Yeah.
Almost. I still gotta enter it, but
Okay. Oh yeah. Go ahead. Hurry.
yeah, I'm doing so. Actually, it's just not saving.
So if I can just list all the questions down for you, just to make sure you're all right, and you can write it down on paper, and you can plug it in a bit.
Yeah, I wrote them down. I'll send you a message tomorrow after we get our internet fixed, and go from there.
Okay, cool. Yeah, I'll just shoot you. I can shoot
we'll
you.
start the next one.
I can shoot you an email tomorrow with just to make sure with all the answers, just to make sure you had them all correct. But okay, let's go to the next one, which is lesson 17. Oh, and don't forget on lesson 16, guys, there is a quiz to talk about. I think it's just asking to make sure we did our report, but there is a quiz on that. So
just asking about if we submitted our report or whatever.
Okay. Oh, if we submitted it. Okay.
Yeah.
So I'll let you know.
And then if we've gotten it approved and stuff.
Oh, so we can't. How do we turn that in? Okay. Well, anyway, we'll figure that out later. Okay. Group meeting quiz 17. Do you guys have any questions on this one at all?
No.
Okay. Well, we'll find. I don't either, but I'm sure as we're going through this, we'll discover some. Okay. So Seth, on this one, can you are you able to at least pull up the Excel spreadsheet?
Oh yeah, I have the quantitative inference procedure.
So we're needing the categorical one.
Try and grab.
So if you did it for the homework, it could possibly be in your recently used. The categorical data analysis.
So I have to still grab the Excel sheet from the.
Oh boy, yeah, That's going to take a while to load up. But we'll punch it in, and we'll tell you what we're punching in, and you can you can review it later once you got a better internet connection. Does that sound okay?
Yeah, you can continue. I'm trying to see if it'll let me just go back and start the next.
Okay. All right. So first two questions are the true false. So answer those however you may. Okay. Question number. Okay. Question number 3. Sorry. Hey, Michaela, are you there? Oh, you're there. Sorry, I didn't have my camera pulled up. So question number 3. Did you get C for just P?
Yes, I did. Sorry, I'm
No worries.
a little bit.
Oh, you're moving ahead. I like it. Okay.
Sorry, my husband's gonna be home at 9, and I don't get anything done after he gets home.
Okay, let's go. All right. So question number 4: are the requirements met? Okay. Well, let's find out.
And that's just to make sure it's over 10 or greater than or equal to 10, right?
Yeah, I can't remember. Do we use P hat or do we just use P on this one?
This one just looked like P.
I think we just use P, right? Yeah.
Yeah, let me go back. I can check. I got the thing open. But
You guys are on number 4.
it's just P, it says.
I think you're right. I think it is just P. I just wanted to.
Yeah, it says, okay, so is it large enough? We can apply the central limit theorem to a sample portion and conclude that P hat follows a normal distribution if both of the following conditions are satisfied, and N P is greater than or equal to 10, or N times 1 minus P is greater than or equal to 10. So yeah.
I have in my, wait, is that on lesson 17?
That's on lesson 16.
I think lesson 17 is different because I have it in my notes for 16, but then for 17, it says that you use P hat instead.
Let me see. Anything. Okay, yeah, in lesson P, it's P hat. Okay.
Okay, cool. So the difference is one, we're talking about true population. Okay, so when we're talking about confidence intervals, I think we use P hat. I think that's what it is. Right? Gosh. So I thought this was, I guess I had a little bit more confidence going into it than I probably should be. Anyway, we'll go back over this later, but I'm pretty sure it's P. We use P hat. So let's go ahead and use P hat. So 0.1 and then N is 100, or 0.1 and then N is 100. So Seth, we're just going to do P hat equals 0.1, N equals 100, and then we're going to solve to make sure it's the shape is normal using the greater than or equal to thingy. So 100 times 0.1.
I got true.
Yeah, so yeah, first one's 10, second one. Yeah, true. So for is true. The requirements are met.
Okay. So what equation are you using for that one?
So the same one, but with a P hat instead of P.
Okay, so that equation, we're solving for, the 3 is, for the true proportion. Okay, yeah, that's just P. Okay, that's C. And then 4, popped up now. So N equals 100, P equals 0.25, P hat equals 0.10. And we're trying to get their confidence of the confidence interval are satisfied.
Yeah, that's what we're trying to find out.
Wait, where are you guys? Did we move on from?
No, we're still on 4.
Okay.
So did you first have to get the standard deviation, or what equation are you using?
We're not using, we're doing the greater than or greater than or less than.
For number 4?
10.
For number 4. Yeah,
Okay.
then 10.
Okay, I'm sorry.
Ready, Brian?
And you plug that into are you plugging that into the probability output?
No. No, Seth, we're just doing greater than or equal to. It has nothing to do with probability output.
Okay. Okay. So did you get 25 and 75, which are greater than 10?
Yeah, well, both are greater than 10, yeah. But we use p hat.
Oh, you use P hat for P?
Yeah, because we use p hat when we're talking about confidence intervals, and then we use p when it's a hypothesis. I know, it's confusing, I agree.
Okay, I'm sorry, now I'm on the same page.
So, but you just did it for p.
Yeah, I did it for the hypothesis. So I should have done it with 10.
But did it work for the hypothesis as well?
Yes, it did.
Okay, so because that's question 5.
Then that's when the hypothesis one is when we use P, right?
Yeah. Mm-hmm.
Okay.
I just confirmed that in the textbook. So 0.25. I'm just going to run through it real quick. Times 100. Okay, we know that's above, and then 0.5, 0.25 minus.
So you got a 10 and 90, correct, for the...
Yeah, so it's true, and true. Yep.
Okay. Question number 6.
Here, so a study of first-degree murder trials was conducted in another state. A random sample of 60 people, so n equals 60, on trial for first-degree murder. Of these, 45 of the defendants were found guilty.
So when it ends 45, and then P.
No, I don't think so. I think P is 60, or no, sorry, N is 45, and sorry, N is 60, and then 45 is X. So I think we just do 45 divided by 60. Because we're solving for P hat, and P hat equals X over N.
So that's 0.75.
So 45 divided by 60, yep, 0.75. Okay, was that 6? Okay, create a 95% confidence interval. So Seth, on this one, we're getting into the Excel spreadsheet. Okay, actually not quite, because we're gonna have to find a confidence interval, or the margin of error. Okay, so determine a 95% confidence interval of the true proportion of first-degree murder trials in the state that were found guilty. Input your answers. Input your answers for the margin of error, upper bound and lower bound. So, okay, so now we just plug it into the, not yet. So right now we're just plugging it into the one sample z-test for a proportion in the Excel. So we do 45 for x, and we do, what was it, 60 for n?
No, it's not 45, it's the z-score, so it'd be 1.960 margin of error.
Wait, what? Oh, no, yeah, no, I'm saying for x, I'm just inputting it into the spreadsheet. So so I got a lower bound of 0.640 and an upper bound of 0.860.
You got a lower bound of what?
0.640.
Wait, I thought we were finding the margin of error.
Yeah, I'm going to go back to that one because because you can solve that one.
Yeah, you get first the upper and then the lower, and then you do the margin of error. So what's the upper did you get?
So upper was 0.866. Let me double check that. So yeah, or sorry, 0.860, not 866. So 640 and 860 and 640. So yep.
Okay.
So 0.64, 0.86. Okay.
I got that the margin of error is negative 0.11.
Can't be negative.
Oh, no, I guess it's, yeah, it's 0.11. That's right.
Okay. 64.
So wait, what's the null hypothesis then?
The null hypothesis, we do not have one yet, but we don't need one right now.
And then are we doing greater than or equal to? Like, I don't. Are you guys using the one sample z-test portion, or
so that,
where are you plugging it in?
So what you're asking right now, I'm plugging it into the one sample z-test for a proportion.
Okay, and x is 45, right?
X is 45.
And then n is 60.
Yes.
Okay.
Null hypothesis doesn't matter right now. The null hypothesis is not needed for a confidence interval.
Okay. Well, then for the upper one, I'm getting 0.860.
That's what I got.
Oh, I thought you got 0.866. That's why. Okay.
I said that at first to correct myself. Sorry. So then we just take what was it? What is p hat equal to?
P hat is equal to x divided by n.
So we got 0.75. Is it the mean? Sorry guys, I'll go back to my notes real quick. Okay, yep, yeah, okay. So then we take the high, 0.75. So we take 0.86, subtract 0.75, get 0.11. Let me try it the other way. 0.75, subtract. Okay, yep, answer for 7 is 0.11.
And that's what I got when I did it the long way too.
Okay. Sometimes you have to do it the long way because when you do it the other way, it rounds. So like it rounds the upper or the lower. So
Right.
if you subtract it, you get slightly different answers depending on how you subtract it. But on this one, you get the exact same, so it works well. if you increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval? It will decrease. So 10 is decrease A. Okay? Suppose, or say, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose suppose 0.5 equals P. What is the smallest n that can be used, that can be both, yada, yada, yada. Okay.
Okay, so that's what we did last time.
I think so. So it's going to usually, so between the two, typically it's going to be the higher number. Just think about that, because I know they're asking for what's the lowest number. The lowest number is typically the higher number.
Okay.
So let's all do that ourselves, see what we come out to.
And so our n is still 50?
N is 0.5, or sorry, no. P, so now we're trying to find n. We're doing that same thing we did last time. So we're doing n times 0.5 is greater than or equal to 10, and then the other one. So,
Yeah.
It would be 20 either way this way, though. Sorry. Because one
you spoiled
half
it
is
for me.
one
I was
half.
looking,
So either way, we're going to get the same answer.
let me put, so it's 10, that's 10 divided by 0.5, so 20. So then let's do.
Oh, yeah. So it's 20 either way. I got that too.
Okay, 20 is the answer. Easy peasy. Okay. All right, number 12. Is that the, looks like it. Okay, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals, okay, same question, Seth, as the one before? All right.
So with 1 to 10, yeah.
Oh, do you have it up, Seth?
Yes, I do.
Oh,
Now I
good.
do.
Good. I didn't know that. Okay. So
I got an
0.1.
answer. Sorry, just now.
Okay.
Are you going to spoil it again?
Okay. So that's 100. What is the, so answer is 100.
Yep, that's what I got.
So the very first one you got 100, so that's
Yeah.
P or 10 divided by P, and then for the next one, did you get 11.1111?
Yeah.
And so the reason why it's 100 is it because it's the whole number, or?
No.
So
So
the other one doesn't work for the other. If you plug it into the other equation, it doesn't work. It's younger.
Yeah.
It's younger than 10. It's less than 10.
it's younger than 10, Seth. No. So yeah, that's where we were confused first, because it's kind of tricky, because in the notes it says what is this, or in the question it's like, what is the smallest number that can be used for both? You think just the smallest number, but that smallest number can't be used for both. It's the smaller number only works for one, but the larger number would work for both. So it's always the larger number between the two. Okay, the conditions for conducting a hypothesis test are satisfied. Man, these are so annoying. Okay. Let's work through this one. This one actually has some meat to it. So
So that's just P times N, right?
this is P.
And then, n times 1 minus p, right?
Yeah. So
Not p, regular p.
so P. Oh, so yeah, we're seeing if 80 is good enough n. So we just times 0.6 times 80. Which actually I don't, which is going to make it. I just want to make sure.
Wait, where'd you get 26?
0.6 times 80.
Oh, I heard 26. Sorry. I was like, where are you getting that?
Oh, sorry.
No, you're good.
So it works for the first one, and then let's do 0.6 minus 1 minus 0.6. You get 0.4, and then 0.4 times 80 is 32. So for 13, did you get true?
Yes.
Okay, cool.
So wait,
Yeah.
how did you test that? Because I got 2.1053.
We're not using p hat. We're using p.
So what equation are you using for this one?
So this one is just the greater than or equal to for 13.
Okay.
There's like 3 in a row.
P is 0.6.
So p is 0.6, yeah.
Okay.
Okay, what is p hat? Okay, p
I
hat.
got 2.105 with that.
So yeah,
Let me know what you did.
it's 38 divided by 80, I believe.
I got 0.475.
Yeah, me too.
So 80 divided by 38, isn't it?
It's 38
Oh, no,
divided
it's
by 80.
38 divided by 80.
So we got 0.478.
Okay. That was my bad on the calculation. 0.475.
78. For 14.
Wait, hold on.
Oh.
Okay.
Wait. X equals 38 and then N equals 80. So 38 divided by 80.
Yeah.
You got 0.478.
Yeah.
I got 0.475.
Oh, sorry. I got 5 too. I don't know what I was saying.
Okay.
I got 0.75.
Sorry, I'm a little dyslexic apparently. Okay. So now moving on to 15. Find the test statistic. Okay. All right, we have to hurry. We got 15 minutes or else Michaela's going to get distracted.
Okay.
Is that right? Is that right, Michaela?
Usually.
Okay. Okay, 38. So now we're just going to plug it into the applet here.
Oh.
Not the applet, sorry, the template in Excel.
I did it by hand.
Oh, here's Smarty Pattardi then. Okay.
I forget that we have the applet. I just didn't even look at it. So let's see. You may get the same answer.
Yeah, hopefully we do.
So this is the categorical data analysis task that you guys are using?
Yeah. That's what I'm using. So hold on, let me double check, make sure I got everything right. So we got X, we got that. So okay, we're doing okay, so it's less than. Did you get your Z-score, Michaela?
Yeah, it matches the one I got. Negative 2.282.
Sweet. That's what I got.
So for the T-score, wait, you're using greater?
So it's a T value, or no, we're doing less. It's less than.
Yes, yes.
Okay.
Have a look at the again. So the Z-score, well, no hypothesis, that doesn't matter.
Yeah, it does.
Confidence
It does.
interval,
It matters for
it does?
Z-scoring. Yeah, it's 0.6.
Is no hypothesis 0.6?
Yeah.
Oh, yeah, yeah. Okay.
All right, but then would we plug the?
And then you guys got for the T-score of negative 2.282.
Yep.
Okay.
And then so we're doing, and it's set it to less than, and your p-value should be 0.11, 0.011.
Yes, that's what I got.
Less than? I thought it was greater than.
So if you look at the alternative hypothesis, it shows less than, because that's what when I was reading it, I thought it was less than too, and I put it as greater than originally, but then I went and double checked.
Oh, it is less than. Right. I looked at that word. Okay, you're good.
So number 17, we reject the null.
Yes, because it's not greater than.
It's because 0.011 is less than 0.05. Yep. Okay, which of the following best summarizes the conclusion of the test? There is sufficient evidence to conclude the water quality has not decreased.
So when you fail to reject, is that when you use insufficient?
No, so fail to reject, insufficient, reject, sufficient.
Okay.
Yeah. I have that written down, like I have it tattooed on my hand right now because I keep forgetting. But so yeah, so the answer is D. There is sufficient evidence to conclude the water quality area has decreased.
Okay.
Alrighty. Have you submitted it? Anybody yet? I'll go ahead and do it first if no one has.
We got them all wrong.
Don't say that.
We got 100. We're good.
Woo! Man, tonight was a doozy, man. Especially because I'm not used to doing it this late.
Only 8. What are you talking about?
It's 8:50. It's usually 8 at this time. Okay, but yeah, good job, guys. I'm glad we got our group project squared away. I think with how we're doing it, so with just the measuring, I think that's the best way to do it. So
Me too.
You will all have. I think we should measure in grams, or whichever. I'll take care. What I'll do is I'll write everything up, and at that point I'll decide whether we'll use grams, because it also uses another calculation. What was it? Ounces.
Okay.
But grams are smaller. I think we should use grams because we can have a bigger difference. We can because our calculations aren't going to go super far. We should probably use a smaller thing as smaller measurement, because we don't have 0.0000. We just have 0.00. So we'll probably just use grams instead of ounces. But I'll confirm that later this week. Other than that, good job, guys. It was a late night, so let's. I think we can save ourselves a lot of heartache, because it seems like we already have a good understanding of what we're doing for the assignment. So
right.
I'll keep you posted where I'm at.
Let me know when you get it. That would be great. So that way, when we take the quiz, we can say yes or no.
But yeah, I will. I'll probably get it done tomorrow, either tomorrow or the next day, and then I'll submit it whenever I finish. And I'll shoot you guys an email and a text.
Okay.
We'll have to start a new group, because because Ed just texted us. He's like, guys, I quit.
Yeah, he emailed us too, or I got an email.
Yeah, I totally forgot to cut him out of the text. So All right. Well, have a good night, guys. Oh wait, Seth, you had a question?
Well, just on lesson 16, so it's finally like loaded. I just want to confirm some answers.
Sure.
On a couple of them. I'm like almost done now.
Okay. Hey, Michaela, he's just confirming answers. If you want to cut out, you feel free to.
Okay.
All right. Crap, I already X'd out of it.
I think I'm right on all of them.
Let's see here. Actually, I think I can pull up old quizzes.
Yeah.
Oh, okay. What lesson was it? 17.
So lesson 15.
16, you're right.
Yeah, I finished 17. I got 100 as well.
Okay. Which questions do you need verification on?
We'll just quick run through.
Yep, run through it. So I'll read them out to you, just from top to bottom.
Wait, 1, 8. So last is 16.
Do you want me to start at 3 and read them down?
Yeah. So I can just do it really quick so then it's easier and you can just compare.
Okay.
Question 3 is C, each slice represents.
Okay.
Question 4 is D, which is the last one, the only difference between
Yep.
is largest to smallest, okay. Number 5, C, true proportion.
Yep.
What is N is the sample size.
Yep.
7 is 40.
Yep.
8 is 0.4.
Yep.
9 is 0.1.
Yep.
10 is 0.3.
10 is 0.35.
Oh, 10 is 0.35.
Yeah, we changed it. I put 0.3 and she put 0.35. 0.35 is the correct answer.
Okay, and the reason why it's I'll have to
because p hat is known, and then I guess if we don't know p hat, p is always assumed to equal p, or p hat is assumed to equal p unless p hat, unless we have a x data. So anyway, okay, number 11 is 0.046.
Yep.
12, 1.087.
Yep.
13, 0.139.
Yep.
14 is 0.011.
Yep.
15, negative 1.818.
Yep.
16, 0.035.
Yes, and the reason how we got 15 and 16 was plugging it into the categorical data analysis tab, correct?
Applet, yeah, oh yeah, in that spreadsheet, that's correct. And she did it a different way and got that answer that was slightly different. It was like negative 1.789, and she put it in the way she did, and she got the right answer as well. So on this one, there's a little
she just around it.
Yeah. Okay. Well, let me know. Submit it. Let me know if you got 100.
Okay. Oh, thank you so much. I'm sorry about the internet.
No worries, man.
I don't know about hotspots, but they finally kicked in a lot after.
Yeah, that's
I got 100. Perfect.
Alrighty. Hey, man. Well, have a good week.
All right. You did the same. Let us know about
yeah.
If you can help with it or need ideas, I can definitely look at this for you as well.
Sweet. All right. Thanks, man. Appreciate it.
Right.
All right. And have a good night.
Bye.